Hey guys, this is Miss Jones. I'm here to talk to you about the building blocks of matter. These are atoms. Okay, I'm going to use the color orange because on chemistry stuff we like to use the color orange. So you guys may have seen this picture before on watching the cartoon show Jimmy Neutron or Big Bang Theory, if any of you guys like that show. Well, an atom has two locations. It has this center part, which is the nucleus. That's the bigger blue circle there. There are some tiny subatomic particles inside of there. And then these three rings here on the outside with the smaller blue circles make up our electron cloud. Okay, so basically atoms are made up of matter, or atoms make up matter, and matter is anything that has mass and take up space or volume. So a brick, a desk, a pencil, air, the computer, the iPad, your phone, however you're looking at this video. You may have heard the word atoms before. This is the smallest possible unit into which matter can be divided while still maintaining its properties. So again, we have the area called the nucleus, and then those three outer rings are called the electron cloud. Okay, so let's start with the first subatomic particle. Okay, now, subatomic particle. This is a huge word that I really need you guys to remember. That's why I'm writing it across the screen here. Okay, so the first subatomic particle that we're going to talk about is the proton. The proton has three things that we need to remember. Number one is its positive charge. So when you think P, think positive, okay? Then it has a mass of 1 AMU. AMU stands for atomic mass unit. So, we don't measure this in chickens or inches or feet or liters. We measure these in atomic mass units. It's so small that you can't measure it any other way. I mean, we can't even see these things. It's not like you can look at your pencil lead and say, oh, I see 1 atom of lead. You can't do that. Then the protons are also located in the nucleus, okay? So when I look at this picture of this hydrogen atom, 2 parts hydrogen make up water. Y'all have heard the formula H2O. So this is one of the 2 atoms of hydrogen that will make up water. So the proton is located here in the nucleus. It doesn't have a circle drawn, so I kind of drew one for you guys. Okay. Next we have our neutrons. Our neutrons are also located in the nucleus. However, a lot of people think that the neutrons have a negative charge. That is not true. So when I draw neutron abbreviation, I draw with an N and then a small O at the top. Okay, I want you to think the word no when you see that. Okay, so neutron means it has no charge or it's neutral. It's kind of like it's neither happy nor sad. It's in the middle, it's neutral. It also has a mass, has the exact same mass as a proton, so it has a mass of 1 AMU or 1 atomic mass unit, also located in the nucleus, as I think I just said. And look, there's the blue one in the middle there. Boom, nucleus. Next we have our electrons. Electrons are negative, okay? A lot of people, mix up the charge of an electron with the charge on a neutron. So remember, neutron is NO, electrons, we're going to draw with an E and a small minus sign. I like to think of it as electrocution or electricity. If an electron touched me, it shocked me, just like if I touched a bare wire. It would electrocute me. That's a negative thing. It's not something I would be very happy about. Okay, so electrons have a negative charge. They have a mass of 1 over 1836 AMU. And so for those of you who are looking at it like this, let me draw it this way. 1 over 1836 AMU. It is a fraction. That means it's less than 1. So the electron is essentially much, much smaller than your proton and your neutron. Okay. The electron is also not located in the nucleus. It's located in its own special place. It is located in these rings here. I'm a horrible tracer on the iPad, guys. I do apologize about that. But this ring and this ring, there's 2 of them. Those are where your electrons are located. That's your electron cloud. I'm going to abbreviate it E cloud. Okay, you guys will learn that. Okay, and one thing we need to remember about the E cloud, that's not only the location within the atom, but it has a special rule about how we draw these things. Okay, it's called the rule of 288. When you guys get to high school, you will be drawing more elaborate Bohr models, but we won't be drawing anything too complex here in the 8th grade. So the rule of 288 basically tells us this. In the very first ring, the one closest to the nucleus, here's the nucleus where our protons and neutrons are. The first ring surrounding the nucleus can only hold 2 electrons, up to 2. So it could have 1, but it could have 2. Once it reaches 2, it's full, no more electrons invited to the party. Then the next ring can only hold up to 8. This is this ring here, okay? It can only hold up to 8. So if you look at this picture, this one has 2 electrons in the first ring and only has 2 in the second ring, okay? And I'll also give you a little cheat sheet. The last 2, those are called our valence electrons, okay? Valence electrons. I should have abbreviated that, but whatever, okay? Valence, I think, very edge. So whatever your outermost ring is, which happens to be this ring here, those are your valence electrons. So we'll abbreviate that V with an E minus, and those equal our reactivity. Hopefully you guys will be able to remember that later when we get into it in a little more depth. Okay, next we have the atomic mass. So you got 2 ways to find this atomic mass. That's the mass of the atom. Remember, we don't use weight, we use an atom's mass. So the mass of the atom, there's 2 different ways you can do it. You could add the number of protons and neutrons. I'll show you how to find that here in a minute. Or you can simply look at the periodic table. So clear that for you guys. Alright, so here is the periodic table. An example is phosphorus. It is an element, okay? So here's my mass, and it's 30.9. So what I would want to do is I'd want to round this number, okay? We always want to round to the nearest whole number. So what do? I want to round to this 0 because it's just to the left of the decimal. So I'm going to look to the digit to the right. It's a 9, okay? I like to think the old elementary saying, 5 or more, add 1 more. So 4 or less, let it rest. So this is a 9, 5 or more. I'm going to take, since it's 5 or more, I'm going to take this digit here, and it's just going to go up 1. So it's going to be, that's why it says rounded to 31. So 30.9 is closer to 31 than it is 30. Okay, so we have our little saying. This is a couple things to remember, and I'll show you guys how to do this on your brain dump. All right, so we have 8-man. 8-man is how we're going to remember how to find protons, neutrons, and electrons by looking at the periodic table. So the number at the very top of the box is our atomic number. That's the A in ape and the A in man, okay? So 8-man is atomic number is equal to the number of protons and the number of electrons. So if I want to draw an atom of carbon, it would have 6 protons because the atomic number is 6, but it also has 6 electrons. So it'd be 6 and 6, okay? Then I have man. Man says mass number minus atomic number equals the number of neutrons. But in order to get that mass number, as I told you earlier, we have to round. Now, sometimes when you look at the periodic table, it will already be rounded, but a lot of times, like the ones you get on your test, will not be rounded, so you'll have to do that yourself. In this case, this one's rounded. Okay, so my mass number is 12. My atomic number is 6. So I'm going to subtract 12 minus 6, and I get 6. So I ended up with 6 protons, 6 electrons, because that's my atomic number. And I also ended up with 6 neutrons. However, you need to keep in mind that this is not always going to be the case. So don't think it's always the same. That is not ever, ever, ever true. Hey, real quick, I want to do 3 examples with you. Let's look at the hydrogen atom. Okay, it says how many protons, neutrons, and electrons do you see? Well, let's look at it. I see 1 proton. I don't see any neutrons. Okay, so 0 neutrons, and this is the only element that doesn't have neutrons. And then I see 1 electron. Okay. Alright, let's look at this one. Okay, I see 8 protons, I see 8 neutrons, and I see 8 electrons. So what I'm going to challenge you is pull out your periodic table. Okay, so as I said, you have 8 protons, 8 neutrons, and 8 electrons. But let's look at this. Okay, this is a periodic table. So if I had 8 protons, what do I know? So think about it for a second. Think about 8 man. Atomic number equals 8 protons and 8 electrons. So I'm looking for an atomic number of 8, and I think I found it. That's this right here. So that means that the element is oxygen. All right, let's look at our last example here. I have 11 protons and I have 12 neutrons. So if I have 11 of these protons, that should mean I have 11 electrons too. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 protons, 11 electrons, 8. Okay. So when I add these two together, because that's how I found my atomic mass, I should end up with 11 plus 12 gives me 23. Okay, so if I have a mass of 23, man is mass number minus atomic number, which has to be 11. If I have 11 protons, I should end up with 12 neutrons, so that does check out. So let's go back and check our periodic table and see what has 11 protons. Alrighty, did you find it? I'll give you a second over. Alright, there is 11. That means we have sodium. So let's double check it. We said we had a mass of 23. If I have 22.9, is 22.9 closer to 22 or 23? 23, it all checks out. So guys, that's pretty much it. The basics of atoms. So you hopefully use this to learn about it for the first time, or use it to kind of help yourself review. So we're going to get some other stuff done in class. Hope this helped.